Hello, everyone. Hello, children. How are you doing? Trust you are having a restful holiday and a break. This is Mr. Yinka, your coding and robotics instructor. And in this class, I'll be teaching you. We have to go over all that we have done in Scratch. Just a brief introduction, and then we'll do one or two things that you can practice while you are at home. And it will be helpful for you to be doing something, practicing on your own, pending when we'll get out of this midterm break, and then we'll meet next week. So let's get right into. All right, so I'm going to go ahead and launch my Scratch. Now, I know some of us already, very few of us at Greenbelt already have Scratch installed on our laptop. So, and to do that, you go to your start button here and you search for your Scratch. You can scroll down here to Scratch. Okay. Okay, so I currently don't have it on this system I'm using, so I'm just going to go ahead and install it for the sake of those that might have the app and don't know how to install it. So you can download the app from online. I can download this app online. Scratch free download. Okay. Scratch.mit offline. That's what I want. Okay. That's been down. It's downloading. All right. For those of us who don't have it, and then we don't want to install it on our laptop, there are other ways to get it. Just go to scratch.mit.edu. MIT, Massachusetts Institute of Technology. And when you are here, just click on create. And you will have the same environment as those that have installed it on their laptops. So the environment is coming up now. Just go ahead and close this. So you notice that the environment is similar to our regular offline Scratch environment. So this is ready. Let me just go ahead and install it. And minimize this. Okay, for me. Okay, so it's done. Let's run the Scratch. Okay, and by the way, just like by way of definition, Scratch is a block-based programming language used for building programs, animation for children, basically. And that is the reason why it is block-based, because you don't have to write code like Java, like C language, like Python, like other programming languages. But the programs, the codes are arranged in blocks. As you can see here, we have move 10 steps, turn 15 degree. These are codes under motion. We have codes under looks, say hello, say hi, think, switch costume, next costume, switch backdrop, etc. Hide, show. We have codes under sound where you can you can program a sound to do other things. We have code under events. They start a program. Basically, we have when the flag is clicked, when you hit any key on the keyboard. We have when you click a particular sprite, when your backdrop switch, when loudness is increased, when you receive a message, and so on. We have codes under control. These are for conditional statement, branching and looping. That's conditional statement, if then, that's if condition, then a statement. We have a looping that allows you to perform a code a number of times. We have if then else statement, wait until, repeat until, and so on. We have codes under sensing. These are event listeners. They listen to event and then they act on it. You have touching, when it's touching a particular mouse, touching a particular sprite, touching edge, and so on. We have touching colors. We have ask. We use this to receive inputs. We have key when you click a particular keyboard key, and so on. We have codes under operator. That's for mathematical operator. The regular plus minus multiply divide, pick random between a number. We have less than, greater than, equal to, and or and not operator. And then we have the join operator and so on. And then we have codes under variables where you can make your own variables that we accept inputs. And then we work that we accept input and then process the inputs to give you a particular output. And then we have my blocks where you can make your own blocks. You can make your own blocks and then program the blocks. We use it for functions and procedures and so on. So that we all define and explain in the course of our programming course. So this is where the blocks are, the codes, basically. And then this is the coding area where you drag your block and you make your codes. And this is the output area where you design your program, build your programs, pretty much like the front end of every, that's the front end of every program or application that you see. You know, for every application that you see, there's a front end, there's a back end. The back end is where you build the code, which is this place that users don't see. Then the front end is where the users see and where they interact with, and where all the magic happens. And what makes the magic happen is at the back end, they don't get to see it. This is where you choose your sprites. Sprites are characters in Scratch that you program to do stuffs. And we have different sprites. You can select from the sprite library, where we have different sprites under different category, all animals, people, fantasy, and some of these sprites are animated by default. And I will explain the reason why they are animated. Some are not animated. Some are not animated. We have dance, music, sports, food, fashion, letters. And then under all, you can see all these sprites arranged in alphabetical order. And then you can also import sprites. You can also upload your own sprite from your computer. You can paint your own sprite. Like you can click on the Canva here, it takes you to this environment, and you use these tools, the color tools, the brush tool, the line tool, the shape tool, that's the square shape tool, this ellipse shape tool, the text, the eraser, and the reshape or contour shape tool to build your own sprite. Then you can also import sound from here. You have different sounds in the library. You can upload your own sound. You can record your own sound. You can also check from the library, just like the regular sprite. We have different sprites with different sounds and so on. So that's about that. So you can also add extension. We have other things here. You can bring out your pen tool we are going to be making use of it today in one of our programs. We have video sensing, text-to-speech. Some of them require internet, like this text-to-speech require internet. Lego Mindstorm require internet. Microbit, these are for robotics, Lego programming. Microbit for robotics. MacMakey for gaming. Translate, Lego Boost, Lego Education, Go Direct Force, and so on. So you can also import this, add this extension if you have programs that has to do with you using those extensions. So basically, we've explained how, okay, we also have backdrop where you can pick backdrop from the library. You can import your own backdrop. You can paint your own backdrop. You can do a lot of things. So we did a simple program. To code is quite simple, and we have done sample programs here. Like for instance, I want to animate this sprite. I can say, okay, let me bring out an event, which also always starts a program. When the flag is clicked, I want the sprite to move 10 steps. So I go to my motion, move 10 steps. If I click on move 10 steps, you discover that the sprite is moving 10 steps. So I want to make it even more, make it continue. So I go to my control, I pick move 10 steps 10 times, and then you see it move 10 steps like it's gliding. Like it's gliding, that's it. Okay, let's say I want it to move forever. I click on it here, move 10 steps. So it is hidden. Now let's come to motion and add a block down here. Just going to scroll down and select if on edge bounce. As I said, move 10 steps if on edge bounce. So each time it gets to the edge, it bounce. Now, I don't like how it's turning. So there's this code here, set rotation style to left to right. Currently is at all around. That's why it's doing like that. So if I set it to left to right, it doesn't turn upside down again. And then if I check the costume here, I discovered that it has two costumes. It has two costumes. You discover that this costume is changing. So I can use this costume to program it and just say, okay, I go to looks and I pick next costume. So it looks like it's actually moving. And that's the principle behind the animation. So that is that about a simple program. But for what we have to do today, just going to stop all this and then delete this sprite alongside its codes. And then for the program we want to do for this holiday, one of the program we are going to do for this holiday is just to create different shapes. Let me bring on my pen tool. I'm going to need it. Now the pen tool is loading. Okay, because I haven't selected any sprite, it's not fully loaded. So let me get a sprite. Let me get this how. Okay, so I have my pen tool here and it's here joined just beneath this block. Let me get this backdrop, this XY grid. Let me pick this backdrop. So let me go to my events and then bring out when flag click. So when flag click, I want this arrow to first go to the origin. Now, if you look at this grid here, we have the x-axis, we have the y-axis. The x-axis is from 180 to minus 180. This center is center x0, y0. So if you go backward, you are going towards x minus. You have x minus 240. You have x plus 240. That means that from this space to this place, we have 480 pixels. and I've explained pixels to us in the class. So pixels are tiny square on our computer screen that allow that is used to measure computer resolution and distance on a computer. So just like we use centimeter, we use meter, that we use pixels on a computer screen. So we have 480 pixels between here and here. We have 380 between here and here. And then at this center, we have 0, 0. So I want it to go to 0, 0. So just going to come here. Now, it's showing x64, y28. If I move this arrow down here, it changes to x139, y7 minus 73. And it's also shown here, x139, y minus 73, which is the current position this arrow is at. So, but I want it to come to 0, 0. So I'm going to click here, put my 0, 0. If I click on it, it goes to the center, which is the origin. So let's say I want to draw a square shape. Just going to come here. From here to here is 100. So to test that, I'm going to say, let me first get my pen to erase all. Let me pick a pen color. Let me leave it at this color. You can click here to select any color. You can even use a color that you know on this screen. Maybe I want to use this blue color here. I'm going to click on this pen to everywhere will become this, and then I will select the color I want to use. If I want this blue, I click here to get this blue. Or if I want this orange, I'll come here, select this orange. So the color is that orange. So I will leave it that. Now, let me make it a bit thicker. Let me set my pen size to say 5. And then let me pen down to start writing. So I want you to move 100 steps. I will say move 100 steps. Then after you move 100 steps, I want you to turn down here. So to turn down here is towards my right. It's towards my right. So I'm going to use this. Turn now. This is 90 degree. If you in our mathematics, we're told right angle triangle is 90 degree. So we're going to make it 90 degree. Then move another 100 steps down here. Or let's say 200 steps down here. 200. Then turn 90 degree again. So this will make it turn this way. So I'm going to make it 90. Move 100 steps. Or let's say move 200 steps here. It's going to move 200 steps here. Then turn 90 degree again up. So this will also make it turn up. Then move 200 steps. All right, so move 200 steps to come back up here, and then move 100 back. Turn 90 degree. And then move 100 step back. So let's see, it's going to go like this. Come to the bottom here. Okay, this is 180, not 200. So that's one thing. Let me make it 180 here. And let's just make it 100, 100, 100, 100, 100. So 100 here, turn 100 here, turn 100 here, turn 100 here. That's 4, not 5. So let's see that. Good. Now, it moves faster because programs are executed in in quick succession. That's in milliseconds or microseconds, as the case may be, depending on the speed of the computer. Now, that's why we are not seeing it. And you notice that it's changing because it's changing in the direction of the arrow. Let's put a wait to understand how it's moving. Let's say wait 1 second. Wait 1 second. And then wait 1 second. Okay. Now that it's turning where I want it to be, let me add another 90 degree here. And then we'll discover that it's not. So now that I have added the arrow, let me run it again. Now, this time around, it's just going to face that direction. So another thing I want us to do is, now we are repeating this statement. Move 100, turn 90, move on, wait, move 100, turn 90, wait, move 100, turn 90, wait. So how about we using a loop? That's a repeat block. So because how many do we have here? 1, 2, 3, 4. So let's just say 4, repeat 4 times, and then we trash all this, pick this and put it here. And then we are still going to get the same code. You can see. So now let's see that this repeat block is very interesting in that it allows you to perform a task repeatedly without having to write the code, write a continuous code. You just nest it in a repeat block. And then we have the repeat 10 times. You can change the value. Then we have the forever. Forever allows it to move continuously. So like, for instance, if you change it to forever and then you put it here, just remove this wait, and then we run it. You can see that it's just running forever. So let's try and nest repeat blocks. Let's next repeat block and see what we can do with it. So I say repeat 4 times, move 100 steps. Now let me see, I want to draw 5 of this rectangle. 5 of this, okay, let's say 4 of this rectangle. 4 of this rectangle. I will put it up here, and then it will engulf the other 4. And then after drawing each rectangle, it turns now it turns, after drawing every rectangle, it turns 90 degrees. It turns 90 degrees. So let me go to my motion. I say turn, I can pick this, any of the 90 degree, depending on the direction I want it to go, and put it here. Now, I want to add a code at the beginning here to make okay, let me leave the code like this, and then let's see what it will do. That's what it will do. It will write, the erase all is what is erasing the code before drawing every new code. That's why we put the erase all there. Now, let's say we want to draw 5 of it. Now, how did I get this 90? To get this 90 is quite simple. It's a simple mathematical calculation that is drawn. You know, in our mathematics, we have, let me bring out my calculator. This goes round. which is like a circle, which is 360. So if you say 360 divided by 4, you get 90. That's where I get my 90. Let's say I want to make it 5, it will be 360 divided by 5 equal to 72. So let me change this to 72 and make this outer one 5. And then let's see what we are going to get. We're going to get 5 squares. Let's say I change it to 6. 360 divided by 6 will be 60. And then I run it, I'm going to get 6. Say I want to make it 12. So 360 divided by 12, that will be 30, right? And I'm still going to get it 12 like that. Let's say I want to remove this set color here and then put a change color every time. That's change pen color by 10. Yes, it's change pen color by 10. I put it after every. Okay, let's put it here and see what it will do first. So each square has different colors. So, but if I remove it and I put it here, so to give us something else. So depending on how you structure your code, this is what we call sequencing. Codes are executed in sequence. You execute the first one, the top one, the next one, the next one, the next one, the next one, and all these are done in microseconds. Computer is super fast, and it reads the code and then does what you ask it to do. Let's say we don't want to draw a square, we want to draw a polygon. Let's say a polygon of 5 sides. A polygon of 5 sides. Now, if we are doing a polygon, let's see. Let's just start with one polygon. I'm going to bring out this code out here. And then I'm going to run this. Okay. It didn't do polygon because we said turn 90 degree. So we'll bring out our calculator and we say 360 divided by 5. Then we have 72. So let's make this 72. And then we run it. We get our polygon. And then you can add, maybe you want to do your 12 polygons. You want to do your 12 polygons, turn 30 degree and all that, change color. Then you get your polygon like this. So you want to do just 6, turn 60 degree. So what I will want you to do on your own is to pick other types of polygon. Like this is pentagon. So you can pick hexagon, octagon, decagon, heptagon. That's heptagon has 7 sides. Then you practice on that. So let me see what you can do and try as much as possible to build something on your own and show me in the next class. So this will be the end of the class for today. So far, we have been able to go over introduction to Scratch and how you can build your Scratch, whether you have the application on your system or you don't have the application on your system. You can go online to scratch.mit.edu.com and you click on project, and then you can do the same thing that I have done here. You can do the same thing that I have done here. You can build your own erase all, go to 00, set pen color, pen down. Okay, we set pen size, pen down. Then you repeat 5 times. Then you move 100 steps, 100 steps, turn how many degree that be now? 72. And then you get your polygon. So you can do that online or offline, as the case may be. So with you should be able to do something, whether you are with your uncle's laptop or your parents' laptop, you have access to any one of them. Just ask them to give you internet. It doesn't take much internet just for you to connect and just build your project. And guess what? If you can sign in here, your project will remain online. You can send it to your friends, share it with your friends and family and all that. So that would be the end for this class. I hope this class has been educating, and thank you for watching. See you when we resume. Bye.